Okay. And by the way, you're on mute, but feel free to take yourself off mute. Okay, so your question is on the first problem?
Yes, sir. So for the step one where you're finding, is this the same? Yeah. Okay. When you find ILO, I think it is. Yeah, you say 20 amps. So I could see the 20 amp source, all that. But how come you can determine that that's 20 amps with that point 0.1 ohm resistor there? Would current just not go down that way, or would it just go in that way?
Sure. So your question is with step one, we want to find IL at t equals 0. So you got our 20 amps, our 0.1. This is IL naught. And your question is, why does all the current go through here and none of it go through the 0.1? Is that your question?
Yes, sir.
Okay. So one answer, the intuition, is that if you've got a current source and it's got a choice, can go through something that has a restriction, or it can go through something that has 0 restriction.
Oh, okay, yeah. That's what I was guessing.
All going to go through the short.
Yeah, that's what I was figuring. I just wanted to ask to make sure. And
but you know, I'm not a big one on all intuition. I like being able to do it both ways, right? I like being able to figure out what's going on from a math standpoint. So the math standpoint is that you've got a current source and you've got 2 resistors. And this resistor just happens to be equal to 0. And this is 0, and this is some other thing. We'll just call it R for now. And how much current goes through that? Well, the current divider says it's equal to the I source, whatever that is, times the other resistor divided by the sum of the resistances. So that's going to be IS times R over R, which is just 1, so that's IS. So therefore, from the math standpoint, all flows through the short.
okay, thank you.
You bet.
I don't want to take time away from anybody else. I did have one more question on this same
Sure.
problem. Okay, so later on, when it's part 2, number A or letter A, then you have I of 2 right there. So that they have selected IL of t equals IL of 0.
I'm sorry, you're doing problem one part A or B?
So the thing they have like boxed around right now,
Yeah.
selected. I have a question. Why did you put IL 0 times e to the negative t over tau?
Yeah.
IL at 0.
Yeah. I took a shortcut there. So remember, our first step is to find I sub naught. Second, which we found up here was 20. Second step is to find tau, which we found over here as being 1/5. Third step is to find I of infinity. And looking at it, I took a shortcut here. I did something I said not to do. I didn't redraw it for time equals infinity. I said, look, the switch is open. There's nothing powering the circuit for time equals infinity. So by inspection, it has to be 0. And so therefore, we can now go right to step 4, which is that I sub L is always at any time t. The formula for it is I sub infinity plus I sub naught minus I of infinity times e to the minus t over tau. So since I of infinity is 0, that all just drops down to 20 times e to the minus 5t, which is what we drew over here.
Okay, great. Thank you very much.
You bet. No, it's a good question, and probably other people had it too. All right. Any other ones on the homework?